Hello. What I'd like to do today is give you a bit of an introduction to our Lasertech survey system, what we call LTS. What we're going to do is just show you how we would prepare, how we would do a survey of a ground floor of a building, a typical ground floor, as you see here on the screen. This is the end result, and we're going to show how we would lay this out step by step using LTS, which is our survey software package. So we have a lobby, 3 offices, and a conference room, and a small electrical room with a bit of an angle. We have some windows, we have some doors, and we're just going to illustrate the process of how we determine these wall thicknesses as well. So LTS runs normally on our pen tablet computers. Our surveyors carry a Fujitsu pen tablet computer, as you see here in the picture, and it would be running our survey software. And it is connected by Bluetooth to a laser disto, which is what you see here. This is the Disto Plus. And every measurement we take, anything over 6 inches, we laser measure. Anything under 6 inches, we record manually with a tape. So obviously today I'm not going to have the disto and the pen tablet. We're just going to illustrate the software running here on the screen and show you the process. So I will be manually entering the distances. So the first thing I'm going to do then is start up LTS. And this is our survey system. And the first thing it would ask for is a street address. So I'm going to enter this, and the operator would be entering this on the pen tablet with the pen. We'll say floor 1, and it allows you to pick a configuration, which is a list of layering configurations. This is a list of various architectural layering configurations for various clients. We're just going to go with our default, which is the National CAD Standard layering. It's all transparent to the field operator. He just sees a list of layers as such. But when he saves the file, these are all saved to the correct layering standard, so the layers will be named in accordance with the layering standard picked. And just to give you a brief overview of the layout here, everything is icon driven as well as menu driven. Every menu corresponds to a toolbar with icons, and our operators, of course, are all trained up on the use and understanding what these icons do. Running on a pen tablet, it's most efficient to be able to pick the icons rather than hunt and peck through the menus. So when we first start up, we have a blank sheet of paper here, and we're looking top down. And this is our surveyor. He's standing here ready to take the first measurement. So let's say I'm in the lobby area here, and we're going to just lay out this lobby. It's 20 feet by 25 feet. So I would hit an arrow key, and I would disto the measurement, and we're just going to manually enter 20 feet. And it draws the first line on the full height wall layer. If I click on that, it highlights it and it shows me its attributes. It's 20 feet, the direction is 90 degrees, and it's the full height layer. I would then turn right, and there's a button on the disto. The operator would actually be hitting the right arrow on the disto, and that would be turning our surveyor. We're assuming this is a square room. We look at it, and we can tell it's square. We would enter the measurement and say it's 25 feet, and then we would turn our surveyor to the right, and we disto the next distance. Now let's say this time it doesn't come out to quite 20. Maybe we disto it and it's 19.95, which is very typical. And then for the last one, instead of 25, perhaps it's 25.04. So we end up back at the beginning, and we can see that we have a little bit of a misclose. I'm going to zoom out. Now there's our full room, and you can see we're very close, but how close are we? The operator would run our little closure check, and this tells them that the length of the chain, we call this a chain, is almost 90 feet, and we have an error in X, which is left to right, of 0.04, and an error in Y of 0.05. It's also expressed as a percentage error, excuse me. But we also put up a traffic light, and the operator is looking for the green light. And if he gets the green light, that's telling him that the error is acceptable. It's not an error, it's just you measure four sides of a room, any room, and you're going to get four different distances. It's never going to be perfect just because of variations in wall construction. But this is acceptable. He accepts it, and the system squares it up. And how does it do that? It puts a little bit of air in each segment. We can actually turn on an adjustments layer and see the amount of adjustment. If we zoom in here, it shows that it added 0.025 to this length, and to this one over here it subtracted 0.025, and the same with the X direction segments. So we'll just turn that off. So that's acceptable. We're just going to save the file. And now the next step, if you go back to our AutoCAD drawing, you can see there's two doors in each wall. And the operator would put the doors in. And to do that, he uses what we call the break tool. And with that, he says, I'm going to break this wall. And where am I going to measure from? I'm going to measure from here. And he would disto that distance. And it's 5 feet, we'll say, and it's a 3-foot door opening. He actually measures the door opening. He indicates he wants it rounded because he might disto it, and it could be 3.02, but we want an actual 3-foot door, so the system will put in an actual 3-foot door. It doesn't adjust the overall wall length, it's just breaking it, and if you click on this line, we see it's on the tracking layer. And while we're at it, we'll put in the other doors. Oops, I didn't click close enough to the line. We're going to measure from this corner, and we'll say again it's 5 feet and it's a 3-foot door. So there's our second opening. And we'll do the same thing again with this wall. We'll come over 2 feet this time, and we'll put a 3-foot opening in. And we'll also measure from this corner 2 feet and a 3-foot opening. And we'll put this door, 2 doors over here. Again, measuring up from this corner, it's 5 feet and it's a 3-foot opening. And one more on this wall. We'll measure down from this corner, 5 feet and a 3-foot opening. Now this is our front door here, and we're going to put a double door in here eventually. And so we're going to come over from this corner here 10 feet, and we measure it, and it's a 6-foot door opening. Now we save again, and the next thing to do would be to put in windows if there are any. And let's just have a look at our AutoCAD drawing. You can see there's a couple of windows here either side, so we'll put those in for now. So I bring up what we call the window tool, and it says which wall, and I'm going to pick this wall, and I'm going to measure over from the door opening, and we're just going to put in one window. The diagram shows all the parameters. So the first parameter is, we're going to say it's 0.2 feet from the door opening. That's the distance from the door jamb. The setback is the distance from the wall to the edge of the window frame. We'll say it's 0, it's flush. The outset to glass is then the distance from the frame to the glass line, which is important for doing BOMA calculations. We'll say the frame depth is 0.6, and we'll say the window width is 4 feet. And then it asks for a type of window: exterior dominant, a non-dominant, or an interior or residential. So we're going to say this is a dominant exterior window, which our operators will need to know that when they're doing BOMA calculations. So there it places the window, and it labels it DOM, D-O-M, and the red line is the glass line. So if we were doing a BOMA calculation, the lease line is going to follow that red line. Now we want to put another window over here, so we just repeat the operation. We're going to measure from there. Everything is the same. We say yes. We tell it which side to put it on, and bang, puts the window in. And that's all we're going to do in this room. The next step is to go into the rooms through each of the doorways and lay out the offices. So we have to first of all move our surveyor. We have to do what's called a go-to, and we're going to move him there. We're still on the full height wall layer, and now we're going to measure that wall thickness. So we would pull out our pocket tape and measure it as 0.5. Oops, I put 0.05 instead of 0.5. I'm just going to undo that operation, and we're going to recorrect it here and put 0.5. And now we're going to work our way around and lay out this office here. So we're just measuring the walls. Let's say we measure 5 feet, and it's a 10-foot deep office by 10. And we come back this way, and again, let's say it's 9.96, and then we come down here, and it's 1.95. Now we want to match. We want to make sure that this door jamb matches the other, so we have a match tool. We just click on this little hand, and we indicate we're going to match that one, and now it puts the same parameters up there, 0.5. We hit enter. And now we do our closure check. We're closing this chain to this known point. Every chain has to be closed before you can move on to the next chain, and this way it fits everything together. So we do our closure check, and we're just a few hundredths of a foot out. Each hundredth of a foot is approximately 1/8 of an inch, so we're out about a 1/2 an inch either way, but that's acceptable. We say yes, and it closes and adjusts. If you zoom in on this point, you can see it's perfect. Now the depth of this room is 9.98 and 9.98. So it's just adjusted each side a small amount. Now we want to put a door in. The door swings in here, so we have a door tool. And it just says pick the hinge point, pick the striker point, which side is the door on. We click inside the room, and it places the door. Now let's say there's, as you can see over here, there's a couple of windows here. So now we have 2 windows. So we're going to place 2 windows in this wall. And these windows are approximately, first of all, we're going to indicate 2 windows. It's 1 foot from the corner. We'll say they're the same setback, and it's asking us to measure the first and the second window. So we measure the first window is 4 feet. Let's say the second window, we measure it and it's 3 feet. Everything else is the same, and oops, we missed one thing. We're just going to undo that. We missed the mullion width. We'll place the windows again, and there's a mullion width. So the mullion we'll say is 0.2 feet, and we place it like so. Now the last thing to, let's say there's, we'll put these other windows in over on this side. We can either do it now or we can do it later. Well, we might as well do it now since we're in this room. This is the way the operator would probably do it. So we have 5 windows in this wall coming up from the corner here. 1 foot, and we'll say 5 windows, and we'll say the first window and the last window are not different. In other words, it's going to make all the windows 4 feet. And we're going to say that, let's say they're non-dominant windows. They're less than half the height of the wall. So we say OK. It says it doesn't fit in the chain. That's still OK. We're still going to place them because we want our windows all straight and lined up. Now the surveyor would next go into the next room, so he would go to this point and start laying out this office. So he would turn and go 0.5 feet, and then he would turn and go, it's about 1.5, and turns here and he goes 10 feet, and you can see we have a wall thickness. just by going in and measuring each room independently. The wall thickness is derived just by the fact we're measuring everything to 1/8 of an inch. Now we turn here and we go 20 feet, and we turn again and we go 20.05, and we turn again and we go 9.95, and we turn here and we go 5 feet, and then we're going to turn and close and adjust this chain. As soon as we go past a door opening where we already have a point located, we want to close and adjust any error to that point. So we do our closure check. Now it's saying we're out 0.45 in X. So obviously I've got something wrong because I'm out too much here. My error in Y is acceptable, so I would have to go back and find the error. So the surveyor would look and he could see that it's either in here or in here. So let's say he clicks on here and he discovers that's not 5 feet. He measures it again and it's 4.5. He must have messed up on his laser shot. So he accepts that, and now he does a closure check again, and now he gets the green light and adjusts. Now we just have this little piece here to finish off, so he would do a go to here, and again we would match this other side of the door, go 0.5, and then he would come across 2.5 and down 5.5, match the door jamb, and close and adjust, and we're bang on. We're perfect this time. So we accept that, and I'm just going to zoom on this. No, let's do a zoom all. Now we want to put the doors in. That's the first step. So we bring up our door tool and we say there's a door here, and we repeat that operation and we put another door over here, and we save our file. The system is automatically saving every minute. We never want to lose a file, but it's good to manually do it as well. Now we just put a few more windows in. So let's say there's one more window up here in the corner, and we say come down from the corner. We're just going to put in a single window. All the parameters are the same. It brings them forward. It's a non-dominant window, and we place it. And we'll go back to our AutoCAD file, and you can see it's starting to take shape. Now we'll lay out a bunch of windows along the top. We have 3, 4, 5, 6, 7 windows along the top. So again, let's say it's 1 foot from the corner, and this time we put in 7, and we say they're all 4-foot windows. Doesn't fit in that segment, which is normal, and it lays them out. Now we're ready to go into the next room. So we do a go to, we move our surveyor here, measure the wall thickness, it's again 0.5, we turn and we go 10 feet, and we go up 9.95, let's say, and then we turn and go 15.05, and then we come down 10 feet, and then we turn and go 2 feet, and then we would match the door jamb again, and we're ready to do another closure. And we've got the green light. We're out 5/100ths in both directions, but that's fine. We accept, and we put another door in, hinge, striker, this side of the room, and there we are so far. So that's our lobby and 3 offices laid out. And we go back to AutoCAD, and you can see now we just have to lay out this conference room, and we'll show you how we do an angle here. So we're going to start down here. We're going to do a go to again. We'll go to this point, and I'm just going to scroll over a little bit, and we're going to turn, go 0.5, and then we'll come down 5 feet, and we'll turn left, and we'll go 9.9. Let's make it 10. Now we have this angled line here. So what we want to do is we tell the system we're going to lay out an angled line, and it says pick the first known point or line you can measure from. So we're going to measure from where we are standing, measure the length of that actual angled wall, and we're going to say it's 10 feet. Now we have to tell the system, okay, we have to take a measurement from some other point or line in our system, in our survey. So we're going to measure from this wall. We're just going to measure the offset, and we'll disto it and say it's 18 feet. And it didn't like that. I see the problem. This one should have been 9.9. Okay, let's try this again. We'll do angle line from here, 10 feet, and from here 18 feet. There we go. So now it's come up with two possible solutions, and this is the one we want, obviously, so we pick that and it draws that angled line. The length of the line is 10 feet and it's at 36.12 degrees. And now you can see in the drawing everything here is square to that angle, so we would just turn and measure, and it's 3 feet, and then we turn again and we find it's 10 feet. And now you can see back in AutoCAD we want to get back onto our grid, and so we have a way to do that. We go into what's called absolute mode, and now we can just force it to go up on the screen, and we are going to measure the length of this line, and we find it's 15 feet, and then we turn left and we go 15 feet again, and then we turn right and we go 1 foot, and we turn left and we go 9 feet, and then we come down 15.5, and I'm just going to zoom in a bit, and again we match the door jamb, come across, and now you can see we have a little bit of a misclose, but that's expected going around angles like that. And we do our check, and we find that we're out 0.28 feet in both X and Y. So there probably is a little bit of an error there, and I'm just making these numbers up, of course, but in reality if we had distoed it and triangulated properly we'd be closer than that. If not, you'd have to go back and check. Seeing as the error was about the same in both directions, I suspect it's probably the length of this line here. Maybe we disto it again and we find it's 9.9. Now we see how that affects our closure. We're still out some, but I'm just going to accept it for the purposes of this demo, and the system will adjust it. And it keeps track of the amount of adjustment, and we'll look at that when we finish. Now the next step, we just have to finish off our walls here. We have a little piece of wall here, so we would match the door jamb, and then we would come down. Let's see, what was the length of this? It was 4 feet, so we're going to turn. Wait a second, what's going on here? Let's just get a little confused there. Let's turn and we measure 4 feet, and we match the other side of the door jamb again, and we close and adjust. That's just fine. Now we have to put our two doors in here. So there's a hinge and a striker, and we repeat that operation, hinge, striker. We save our file, and now we just have to put our remaining windows in. There's 3 windows up here. So we come from this corner. Let's say it's 0.5 feet, and we have 3 windows like so, and then we have a couple over in this wall, 2 windows. And then we also have a couple down on this wall. So we measure up from that corner. Again, it's, let's say it's 1 foot. Otherwise, everything's the same. And there you go. So we go back to AutoCAD, and you can see we have pretty much everything except for this electrical room. Now at this point, what we want to do is do a chain around the perimeter. We always do that if possible, and we're going to need that in order to lay out this electrical room. So the first thing we do is we go down here, and we measure the wall thickness, and we find it's 0.6, and then we start measuring around the outside of the building. So we have 21.1, and then we go up 31.7, and then we go to the right and we find it's 46.2, and we come down 1 foot and we turn left and we go 15.1, and we come down 19.8. Now at this point we want to be on the same angle, so we match that angle, except now we would disto it and measure the length of that, and we find it's 10.2. Oops, not 10.2, but that should be 18.2. So I'm just going to correct this, 18.2, and it adjusts. And then we want to get back onto our grid, so I'm just going to go on to grid, and we measure, and we find it's, I don't have a measurement for that one. I'm going to cheat here just so that we can get our drawing closed. I'm going to measure the distance from there to there. The system tells me it's 19.55. So I move Bob back here. Bob is our little surveyor. And again, we get onto our grid, and we go 19.5. Get back to relative mode, and I match the other side, and we close and adjust, and everything is good. We accept it, save our file. Now while I'm here, I'm going to put in our set of double doors. We have 2 doors swinging to the outside. So what I'm going to do here is I'm going to zoom in first of all. I'm going to move, and we're going to pull up a we have a symbol here. This is our symbol manager, and in here we have a set of double doors. So here's double doors. Now I know the length is 6 feet and the width is 3 feet, and we just snap that in there like so. So there's our double doors. Now the next thing would be to put in the door opening over here and lay out this electrical room. So again, we do a break. We want to break this wall here, and we're going to measure up from this corner, and we find it's 12.2, and the door opening is 5. Let's say it's a set of double doors again. Now we would move our surveyor here, measure the wall thickness. We find it's 0.5. We turn and we come over 1 foot, and then the depth is 2.5, and across this way it's 8.9, let's say. Oh, that's a little bit too much. It's probably 8.5. And now we're just going to match our angle here and get back on the grid, and we come down 3.2, And then we want to match our angle here again, and we go 0.5, and then we match the door jamb again this side, go 0.5, and we close and adjust, and we got the green light. Everything looks good. Now we just want to put in these double doors, and another way to put in a set of double doors, I'll show you this way. We could put the hinge point there, and for the striker point we're going to say it's the midpoint of this tracking line. So we have a snap midpoint, and then we just place the door. Now we repeat and we say hinge, striker. We have a point there now, and there's our set of double doors. So we could have placed the symbol or placed them individually, either way. Now the only thing left to do is label our rooms. So we have a text manager, and it comes up, a text editor, I'm sorry, and our operators in the field have some shorthand codes, but I'm just going to type this out since I'm not on the pen tablet, and we're just going to place that text right here. And now we're going to copy this text out. I'm going to select it, I'm going to copy. From there, I'm going to turn off ortho mode, which copies it orthogonally, and now I'm just going to copy it anywhere, and we'll place one there, and then we'll select it again. Oops. Select it again, do another copy to there, and then we're going to put another label in the lobby. We'll call that lobby. We can control text size, but we're just going to go with our default label size, and we'll put one more label over here, conference room, and there we go. And we go back to AutoCAD, and you can see we have everything, and we'll bring up some statistics on the drawing. The system is keeping track of our accuracies. It shows me that our overall floor accuracy is 0.1582%. There are 9 chains in the survey. That's the total length. The total adjustments in X, about a half a foot, and the same in Y, approximately 0.64 feet. And so the overall accuracy is plus or minus 0.15%. Which is about typical. Usually we're within 0.05 to 0.25, somewhere in that range. And keep in mind, BOMA says any two surveys that are within 2% are considered equal. So you can't get much more accurate than this. And we'll save that. And that concludes our demo. We will do some other demos and show how we add to this drawing, such as adding in electrical and ceiling, but we'll leave that for another time. So thank you for watching this, and I hope it was helpful.